So we're going to draw our best normal curve and play with it. All right, so we're going to play around with IQs and z-scores and probabilities. So here's my normal curve. If I'm talking about z-scores, then 0 is in the middle for z. 1 standard deviation to the right is called 1 for z. 2 standard deviations to the right is called 2 for z, and so on. On the other side, 1 standard deviation to the left would be called what? -1, right? All right, you guys are masters of z-scores. Now, there's an idea called IQ, intelligent quotient. It's a pretty good measure of what kind of aptitude somebody has to do math. It's not much of a measurement of anything else. Okay? So, for example, when I know these brothers, and their elementary school did IQ tests, and one brother had this like off the charts IQ, okay? And the other one was just like barely normal. You know, what does that mean? Well, I mean, the parents thought, let's put all our energy into the high IQ kid. He's going to do a lot. The high IQ kid turned out to be kind of a social deviant. Yeah, he was pretty good at math, but he had troubles with a lot of other things, problems with authority, couldn't hold a job. Not socially, he was an idiot. Not all people with high IQs are social idiots, right? That's a whole nother thing. Some people are really good in groups, others are not. I know some really dumb people that are amazing socially, right? And the other brother, who was like below average on IQ, makes hundreds of $1,000s a year, has this $1 million house, tons of cars and boats, and so from the parents' point of view, I think they think that one's now the more successful one. Okay, so my point is IQ kind of doesn't mean much. I put 0 weight in it. Average IQ is considered to be 100. Okay. So for IQ scores, mean is considered to be 100, and standard deviation is considered to be 15. Yeah. So if I had a mean of 100 and I went 1 standard deviation to the right, what number would I be at? I would be at 115. And if I went 2 standard deviations to the right, I'd be at 130. So a z-score of 2 is the same as having an IQ score of 130. They're one and the same idea. Okay. If I went 1 standard deviation to the left, what IQ score would I be referencing? 85. And if I go 2 standard deviations to the left, what IQ score am I referencing? Almost. 70. Yeah, it'd be 70. Okay. So we're just going to worry about those for now. The empirical rule states that about 68% is within 1 standard deviation of the mean. I want to calculate what is the probability that an IQ score is between 115 and 85. And so I'm going to do that on the TI and on Excel. And all the programs have slightly different notation, so I put a summary of the notation on our course website. The book comes with that calculator cheat sheet. That's kind of nice. So let's see, bluecc.edu. Oops, wrong one. This one, come on, there you go, log in. So depending on whether you use Excel or Google Spreadsheets or the TI, I just posted an announcement that is a summary of what buttons to push to make the right calculation, and I have pictures to go with it. One thing, as long as we're doing normal stuff, from now on, you should, I would recommend writing down the probability you're trying to find, writing down the calculator notation, and drawing a picture of what you're doing. I'm going to do that every time, and I'm going to expect that on the test. So here, can you see that? Do I need to blow it up a little more? Oh, that kind of sucks. I wonder if I can bounce that into another window. Sort of. That's a little better. Okay, that's better. So again, empirical says about 68%. On the TI's got really nice notation for this. We're just going to do a normal CDF from -1 to 1. Now here I have a 0, 1 mean and standard deviation. What's the mean and standard deviation for our IQ? Yeah, so I'll just go over these. GeoGebra, GeoGebra, Google Drive, OpenOffice Calc, Microsoft Excel, they only calculate left-hand tails. So to do an interval, we have to subtract 2 tails, and I'll explain that as we go. All right, so as far as the TI goes, this calculation is really easy. On the TI, we're going to go normal CDF. Remember I mentioned another option on the calculator called the normal PDF? Will we ever use that? Never, ever. It is not useful for us. And what the calculator wants is it wants the lower or left side, it wants the upper or right side of the interval, it wants the mean, and it wants the standard deviation. That's what the TI wants from you. Lower or left, right, mean, standard deviation. So for me, I would be typing on the calculator normal CDF, 85 is my left or lower side, 115 is my right or upper side, mean is 100, standard deviation is 15, close the parenthesis and hit enter. I'll do it on Excel. Do you already got it on Excel? Figured out or? Okay, yeah, Excel is a little weirder. But more often than not, I actually do this on Excel than I do on the TI, because I'm more often at the computer. And what do you get when you do that? Yeah, it's 0.683, which is close to 68%, which is what the empirical rule says. Okay. If we were to do this with z-scores, what numbers would we enter for left, right, mean, and standard deviation? Yeah. -1, 1, 0, and 1. Oops, I meant to change color. So if we were using z-scores, we would enter -1, 1, 0, and 1. And that's the z-score calculation. Just do that to see if it should be exactly the same number. And then I'll show how you do it on Excel. Excel has the command norm.dist. Does that sound right? Okay. And it wants, let's see, x, n, mean, standard deviation. Okay. So it wants x, mu, and sigma. And what norm.dist does on any spreadsheet that you use, it only does left tails. Oops. Yeah, sometimes. Yeah, I know. Okay, I have issues, I know. All right, so it's the left tail. So what I have to do is if I want an interval, I take one left tail, and then I subtract the lower left tail, and that leaves what's in between. Okay, so on a spreadsheet, I have to do the upper left tail minus the lower left tail. Oh, only if your boundaries are equal, are symmetric z-scores, and that's not always going to be the case. It's not always going to be the case. I just picked it to be that way right now. We'll do a different example in a minute. So in this case on Excel, I would do norm.dist. I'd have an equals in front, and then I would have 115, comma 100, comma 15, minus. Oh, right. Yeah, yes. Because we want cumulative. Yeah, and the false we never ever use. It's just worthless to us. Yeah, so cumulative true. Thank you. And then it's minus. No, I don't think that's the same. And on the other side, I have the 85, 100. 15, true. And since I jump back and forth between the different devices often, every once in a while I have to remind myself. Fortunately, Excel tells you what you're supposed to type, which is nice. and it's usually understandable. And then you hit enter, and you should get about 68%. Yeah, so about 68.3-ish. So we're going to get the same number no matter what. Okay, so we got to be used to whatever our calculating tool is. Yeah. Okay. All right. So if you forget what to type, I have pictures here of what the area I'm calculating is and what to enter in whatever technology you use. And I picked 5 different pieces of technology that are popular. You can, yes. I would be fine with this. I'll print it out and hand it out with the test. Sure. Remind me at test time. Okay, so let's do a different problem. So let's suppose I mentioned those 2 brothers I knew, that brother number 1 had an IQ of 97, and brother number 2 had an IQ of 125. So what I want to know here is, well, what is the probability that anyone would have an IQ in between those 2 numbers, 97 and 125? And whenever I do these calculations, I draw a picture with them. So I'm going to attempt to draw a picture with this. Less than or equal to. There we go, thanks. So in the middle is 100. And 97 is, you know, pretty darn close. Let's see, 1 standard deviation to the right was what? 115. 2 standard deviations was 130. So that means 125 is going to be about right here. Uh-oh. Pen is starting to die. And so I want to find the area between these 2 red lines, which happens to be the probability. All right, so use your piece of technology to find that probability, if you haven't already. The probability that an IQ score is between 97 and 125. What's that? Oh, we're going with the mean is 100 and the standard deviation is 15. We're still playing with IQ scores. So 97 would be our lower here, correct? Oops. Standard deviation is 15. 125 is our upper, correct? Yep. Okay. So here's GeoGebra's rendition of this particular normal curve with a mean of 100 and a standard deviation of 15. I'm going to do that right now. So I'm going to do the integral of my function f of x from 97 to, what is it, 125 is what I said? And it's thinking, zoom, there it is. GeoGebra says it's about, if we round it to a whole percentage, 53% is what GeoGebra thinks. It's below that up so the world can see. Oh. Okay, so GeoGebra thinks it's 53. If I went to more decimal places, rounding like 5 decimal places, GeoGebra thinks it's 53.147%. Is that what you guys got? Okay. So again, there's tons of technology to make this happen. You keep getting point? Okay, 3.6. All right, so let me check on my TI.
My TI is automatically changing at 97 to 85.
Oh shit. Okay, oh, you've got the Inspire.
Well, it's set up as an 84.
Okay, so we should be able to go paste 97.
See how it pops up as 85? Like it automatically changes.
It didn't for me. Somehow.
I hit it 4 different times. And
Okay.
I kept changing it back.
All right, why don't you try it again just to make sure. Okay. So that's not too bad. So Michael, so sometimes these z-scores aren't symmetric, or this IQ scores aren't symmetric, in which case we do have to be careful with it. What are the z-scores here? I'm kind of curious about that. Anybody know how to find a z-score? How do you do it? Almost the mean from the value and divide by the standard deviation. So we could calculate the z-scores for each of these. So for example, for 97, it would be 97 minus 100 divided by 15. So that's what, -3/15, which is -1/3, or approximately -0.33. So does that make sense that the 97 is a third of a z-score to the left? A full z-score to the left would be 85, right? Does that seem reasonable that 97, an IQ score of 97 has a z-score of about -0.33? Oh shit. All right, I can't do arithmetic today. All right, so it's 0.2, -0.2 then, right? Yeah, so that's -3/15. Oh yeah, that's -1/5, not -1/3. -0.2. Okay, 2/10 of a z-score away from the center. What is the z-score for the 125? What's the z-score for 125? It's between 1 and 2, closer to 2. Almost. 1.66666, yeah, okay, that sounds right. So 125 has a z-score. Whoa, oh my gosh.
Yeah, what you doing?
I don't know what I'm doing. I broke my pen. Oh, it finally stopped. Okay, let's see if I can undo that. All right, I'm going to give it another try. I might have to give up the pen. Oh, there we go. Z equals positive 1.67 roughly. If we go to 2 decimal places, we could call it 1.67. That's that z-score. So I could do this calculation with z-scores instead. Now, what's the mean and standard deviation for z-scores? 0 and 1, right? That's what we call the standard normal. So just a reminder from last class, the standard normal which is also a z-score distribution, has mean 0 and standard deviation 1. And so in the homework problems, and in a lot of problems we do, we're going to bounce back and forth between z-scores and other things. All right, one more question and then we'll quit. Percentiles, remember those guys from the last section? Percentiles are really important for normal distributions. So what I want to do is I want to calculate, for example, what is the 95th percentile and what does that mean? Correct, yeah. So if I draw a picture of that on a normal distribution, maybe somewhere over here is an IQ or a z-score. I don't know which one, but 95% lies below that. Okay. Now, the problems we've been doing, we start with IQ scores and spit out probabilities. Here we want to go backwards. Given a probability, we want to spit out an IQ score or a z-score. That's what's called an inverse normal. What's that? Inverse normal. And I've got all these formulas mangled up in my head, so I'm going to look back here. The last thing here, so whoa, on Microsoft Excel, it's norm.inverse. On the TIs, it's INV-NORM, inverse norm. Yeah, I said the backwards. Okay, norm.inv is Excel, inv norm is TI-84. And fortunately, their notation is the same otherwise. It's the percentage, mean, standard deviation. And what that is really is a percentile calculator. It identifies what value marks that percentile. Now, is a percentile a left tail, a right tail, or an interval? Okay, so an interval is where I'm in between two numbers like this right here. Yeah, it is only a left tail. It's only a left tail. So sometimes, though, we want to do right tails. How do we deal with right and left tails together? Yeah, 1 minus, right? We just do 1 minus. Okay. So what is the 95th percentile for a z-score and an IQ score? The IQ is 124.7? 124.7. Now, we could either turn that into a z-score manually. How do we do that? Yeah, so on the TI, we would go INV norm, which is right near the normal distribution. Norm. 95%, 100 is the mean, standard deviation is 15. That's how we calculate that. So again, so what is inverse norm? It's essentially a percentile calculator. It tells you what value in your data marks that particular percentile, is what it calculates. Now, we could either do 124.7 minus 100 over 15 to get the z-score, or to get the z-score, we could do the inverse norm on 95% with a mean of 0 and a standard deviation of 1. Because when you go with a mean of 0 and a standard deviation of 1, you are always talking about z-scores. All right, so I'm going to calculate that one to back it up. Option 3 on the TI, area is 0.95. Is that a left tail, right tail, or interval? Left tail. Inverse norm is always, always, always left tails. And I get a z-score of about 1.644-ish, 1.645. That number is going to come up again and again in the next several chapters. 95% is a popular percentage in probability. And its associated z-score is one we will have memorized by the end of the quarter. Okay, so we're playing around with section 6.2 and 6.3 here. We get a little more work to do in 6.3, and we're going to start 6.5 on Monday. We are skipping 6.4, 6.6, and 6.7. We're only doing 3 sections in chapter 6. Okay? All right. Have a weekend. Oh, I put